Hello and welcome to the latest edition of the Cloud Native Now podcast. I'm here once again with Paul Nashawati, and we're talking about all things related to cloud native computing. And we're going to start off talking about microservices. Hey, Paul, welcome to the show.
Hey, great to be here. Great topics and great conversation to be had on this day.
We've been banging on this microservices drum for quite some time, and I kind of feel like maybe I should open up like a little therapy office for developers, because it seems like everybody's kind of stressing out about all this stuff. And we have a couple of articles on Cloud Native Now this past week with some advice about how to deal with all this, and we recommend that, and go check them out, please. But what is your perspective on what's going on here? Because there are folks who are, they get involved and then they throw up their hands and want to go home to monoliths. And then there are others who swear by it. And it seems like we're all over the place.
Yeah, it's great kind of conversation to have. And I'm glad to be on this discussion, this week's conversation, because I think that there's a lot to talk about when it comes to microservices. As you or the audience may know, or as you know, I cover the application development and monetization practice at Futurum. And one of the things I cover and I talk about in the narrative is the context of past, present, and future when it comes to applications. And there's a ton of applications that are still in this monolithic past kind of state. And those applications that are living in that state are really, organizations are really looking, there's a desire to modernize, right? And modernization doesn't come just for the fact that, hey, it's the new cool whiz-bang thing to do. It's because of security issues. It's because of resource issues. It's because of, whether it's, ESG issues, with all sorts of reasons, data compliance and regulation. All sorts of reasons why organizations are looking at modernizing their applications. And when you look at microservices, a lot of challenges organizations run into is the fact that there's skill gap issues, right? There's modernizing into from heritage applications to microservices requires an understanding of how to break down that application. So there is a huge desire to move forward from a modernization perspective.
What exactly are we modernizing? Because it seems like a lot of times, if I look at the history of cloud, 90% of it was lift and shift. Okay, that's great. And, basically, you're a mess over here. Are we going back into those applications and carving out the functions that lend themselves to be more like microservices so that they are reused and exposed through an API? But the bulk of that application is still somewhat monolithic?
Well, I guess the way I would frame it is when I tell and talk to organizations, I talk about this maturity model of application modernization. And in that maturity model, I have 5 phases that I talk through. And first phase is when you have the heritage or monolithic applications, okay? And then from there, the next level of maturity is to encapsulate and make that monolithic application into maybe a VM, a virtual machine. And then from there, maybe in phase 3 would be moving from a VM to a fat container. And then from a fat container to phase 4, which would be to move that fat container to microservices, breaking down that application. And then phase 5 will be having a fully elastic cloud native application. Now, organizations can have applications that live in any one of these stages or these phases because not all applications need to be refactored. And frankly, you're not going to. Maybe you'll have applications that go from phase 1 to phase 2 and get encapsulated in a cloud-ready state, but then never mature anything more than that. Those applications may stay as a system of record, and then new applications may be built as systems of engagement that access that environment. So it's not just about modernizing for the sake of modernizing. It's not just about moving to microservices. It's really about the advantages to move to microservices, to have fully elastic environments, take advantage of those cloud native architectures, and then also the portability across multiple clouds if that's needed.
Well, I scratch my head sometimes because I'm a simple guy. And I can't help but wonder if we're overthinking this, and that to a certain degree, everything is a service. There are microservices and mid-sized services and monoliths that are essentially services that I'm calling through APIs, and you can call those big ass microservices if you want. But do we just need to have like this microservices mindset and not get caught up with how big is a particular microservice in any given?
Yeah, and that's a great question. I mean, it really, I would have to say it depends on the business need, right? The reason why you would want to break down these applications into smaller microservices is because there's less of an impact to the overall ecosystem when you have to do an update to that individual service within that application. Also, the other factors to consider is when you're looking at when you're looking at security, it also means reducing the attack space by breaking down that application into smaller components and having less of an attack space by having those smaller components. So it really does depend on the application and the organization's maturity model.
And some of this has to do with maintaining availability of the application, right? Because microservices, if there's an outage somewhere, you can reroute API calls to something that's redundant and maybe keep that application going. Of course, you might drive yourself crazy looking for where that outage is for several months before you figure out the 3 minutes worth of work that's required to fix it. And then other folks would say the monolith, is a little easier to deal with, maybe if for a small team or an individual developer. But if something goes wrong, the whole app crashes and you're out of luck.
Yeah, and again, I think it comes down to breaking down that application environment and the ecosystem, depending on where you want to isolate the problem. You can isolate the problem down to the individual service and not bring down the entire ecosystem. That's an advantage of having a microservice. And that's why there's a desire to move to that, what I was calling that phase 4 of the maturity model of applications. Now, again, sometimes what will happen is heritage applications will be encapsulated and left into a fat container so they could take advantage of, say, Kubernetes and the orchestration layer to manage the entire application layer. But you still want that ability to isolate smaller sets of the environment so you can basically manage that environment appropriately without having to bring down the entire application to do so.
Do you think developers tend to give up a little bit too soon moving to microservices and they run back to monoliths when that happens? Or did they just make the wrong decision up front and then they make the right decision upon further review, and it's just the nature of whatever the project is?
Developers are looking at ways to modernize their entire ecosystem. Okay. So when I started this conversation, I talk about the narrative of past, present, and future. What we're not talking about here is where I go into future. And sometimes one way that organizations will overcome the complexities of microservices is to utilize technologies such as WebAssembly, for example, bypass microservices altogether and modernize to a cloud-native environment using WebAssembly where appropriate. I mean, that might be a good solution for, say, edge locations or locations that have different underlying hardware architectures, so you don't have to recompile the code and just use that application in a cloud-native space on whatever architecture is underneath it. Right? So that's an option to not go microservices, but to go WebAssembly. Now, is that ready for prime time? Probably not for all applications, but it's definitely an alternative to learning the skill set of developing all applications or refactoring all applications within a microservices architecture.
All right. Last question on this particular topic, but do you think AI might one day make it easier for us to cope with all this stuff?
Oh, AI is the answer to everything, Mike. It really is. I mean, it's going to solve every problem that we have. Now, I think that... Yeah. Well, I think that AI definitely is an enabler for increasing productivity. It's definitely an enabler for helping where some organizations may be looking at utilizing AI to help with that refactoring opportunity, but there still needs to be a human in the loop. I mean, there still needs to be an understanding of how to utilize those codes or those refactored applications and make sure it's really appropriate for that organization's needs. Ultimately, AI is a tool, and the organizations cannot default on the fact that AI has produced something, therefore the organization is not responsible for what it created. That's not true. If an organization uses a tool and that tool creates something, that organization is still responsible for what it's been created. So AI can produce junk as well as it can produce good quality results. And I think that human in the loop is still required today to help accelerate those efforts.
All right, let's shift gears to, I don't know, if you've heard, but there's this little brouhaha going on around Broadcom and VMware. It seems to be getting a lot of attention these days. And almost everybody who provides some sort of rival platform has mentioned the fact that A, they exist, and B, you can run something on their platform. The latest is Mirantis, which is talking about some new capabilities that they add that kind of resemble some of the capabilities you might find in a VMware environment on top of their instance of OpenStack that runs on top of Kubernetes, and they're making that a little more resilient. How feasible is it to actually move a workload that sits on VMware over to something else? I mean, is this a project that's easy, or is it'll take a long time? And does that not wind up being more costly than just sucking up the bill from VMware?
Yeah, it's a great question, Mike. I think that many organizations are looking at alternatives at this point. They're just trying to understand what's available in the market, given the changes that are happening with VMware from Broadcom and what Broadcom is bringing to the table. There's definitely licensing costs. There's definitely changes. And like you said, there may be reasons to just stay on a VMware platform because it's the most, quote, cost-effective way to do it. However, many organizations, including Mirantis's OpenStack that runs on top of Kubernetes, offer ways to as alternatives. There's a porting cost that goes along with moving out of a VMware environment to another environment. The vendors that are making it frictionless and more seamless, like Mirantis that has with this solution that they're providing, those vendors are going to provide ways to make it easier to move off of those environments. But if you recall, this was back in the early days of VMware, this is what VMware's kind of approach was, right? If you remember P to V, physical to virtual, and virtual to virtual, and virtual to physical, those were all tools that were used back in the day in order to migrate from a physical environment to a virtual environment. Now we're looking at that V to V, the virtual to another virtual environment, or virtual to container, V to C, using tools like KubeVirt and other technologies to kind of get you there. Mirantis OpenStack for Kubernetes is another tool to kind of get you there. Definitely worth looking at. They have the open the alternative to Open vSwitch for software-defined networking. That's another alternative that they have to offer within their tech stack. And their OpenStack for 2024, which is the code name that's using Caracal is the kind of the code name that they're using. But basically, this is using ways to use open source and software-defined storage technologies to help with those more advanced kind of applications that are running within VMware environments to move over to Mirantis. So there's options. I would say definitely if you're in that space to explore, to go ahead and check out Mirantis. But to answer your original question, Mike, this is not going to happen overnight. This is not a change. It's like, okay, I found a solution. I'm going to move right now. It's going to be a staged approach. As organizations are looking at their renewal costs and their licensing costs, and they're moving from their heritage environments or their previous environments to a new environment, Mirantis is an option that they can move to. There's many in the market right now that are going after the same space. I think it's up to the organization to decide what is the right approach for their own business needs.
How much of this is going to be more like, I'm just going to draw a line in the sand and say, every new workload I build, I'm going to put somewhere else, and just try to contain my losses per se, as it were, if I perceive it that way, versus going back in and messing around with moving data and workloads?
Well, I guess it depends. I mean, if you're going to move your environment from a VMware instantiation to a KVM instantiation, for example. You're moving from one virtual environment to another. Is that really the direction that you may want to go? One may seem more portable. You'll have licensing costs to consider with different models there. But is that the objective? Because previously in the conversation in this video, we were talking about, moving to microservices, right? If the goal here is to modernize and move that VM to a microservices architecture, is moving to another VM strategically the right direction to go? Or maybe what you do is you take that heritage environment that may be on a VM, a VMware VM, and you may want to move it to a KVM solution to reduce the licensing costs, but keep it as a cloud-ready state as a system of record, have it left in place, and then build new systems of engagement in containers to have that modernization effect across the board.
All right, folks. Well, I would just point out one thing. If you're doing something because you're mad about it, count to 10, because chances are it's not going to work out the way you think about it. All right. Next question. We're on to security. We have a couple of pieces on Cloud Native Now talking about how to secure Kubernetes environments. And I think this is becoming a bigger issue simply because there are more Kubernetes environments showing up in production environments. But I always felt that security was a little bit of an afterthought in the land of Kubernetes. So is that getting better? A lot of people specifically complain about role-based access controls, and it's just complicated.
Yeah, security is something that I think that it's important to go slower in order to go faster, right? You have to have security as part of your strategy whenever you're looking at modernization as well as Kubernetes deployments. If you don't, you're making your environment and your organization vulnerable to those security issues. With regards to Kubernetes and security, I mentioned reducing the attack space by utilizing microservices and having Kubernetes to allow you to do that. We see that 71% of container workloads are open to root privileges, which opens up a whole bunch of challenges, as you can read this in the article that's on Cloud Native Now, right? That basically we're seeing that those challenges that, those need to be taken into consideration before you do the actual deployment. So there's a faster deployment model for containerization in Kubernetes. So we're seeing more exposure in security, but that needs to be at the forefront of the modernization effort as part of that pipeline.
All right. Now, in a somewhat related conversation, but whenever the things go bad, disaster recovery always comes to mind. And we got a little wake-up call this past week with hurricane slamming into Texas, and now rain, pretty intense rain at least, working its way through the southeast. We're probably going to see more of these storms this year, or so they are forecasting. What makes recovery in Kubernetes environments perhaps a little more challenging than other environments, and what should people be thinking through here?
Yeah, I mean, this is where a lot of organizations in our recent survey indicated that they're running 92% of respondents actually indicate that they're running on 2 or more clouds. 65% are running on 4 or more clouds. And application portability was considered to be critical by 20% of the respondents. And because of that, this is the BCDR story is incredibly important because of either man-made or natural disasters. I mean, there's natural disasters like the hurricane we just saw and the storms that are coming through, but there's also other disasters that occur. But business continuity needs to continue to happen. And the business continuity that occurs needs to continue to drive ways around it. Now, you asked about Kubernetes being and containerization being a little bit more complicated. Well, that's because there has to be integration between the storage layer, so the data moves with the application appropriately, so where the application is moving. So synchronizing not only your application, but your data sets to go along with it is equally important. And that's where you run into challenges with using different technology stacks and different ways of deploying with Kubernetes versus traditional models where it may be an all encapsulated environment versus a more distributed environment that you would find in a Kubernetes or microservices containerization environment.
Yeah, and for all the talk of hurricanes, I sometimes feel like these incidents are more likely to involve silly things where somebody just accidentally kicked over a box and then took down the pods of the cluster, and we don't have a way to respond.
Yeah, I mean that to me is an architecture design challenge. I mean, I think that if you don't architect redundancy within your environment, where you have an active or an active passive kind of environment, where if a box get kicked over, then they can flip on the other one more seamlessly. That would be an architecture design deployment model. And again, there are many solutions in the market today that can address both the storage backend as well as the microservices and containerization front end in order to do that orchestration appropriately. So and frankly, you can do it automated. If there's redundancy, and if you're pinging a host and a host is no longer there, it'll automatically transfer over to another host. So these things are in place today, and they're available. But again, I can't stress the importance of the way the architecture is delivered and deployed versus making a single point of failure.
On the plus side, it looks like all the vendors in the backup recovery space are discovering Kubernetes. We saw Rubrik is adding support for Red Hat OpenShift, and there's probably going to be a lot more of these things. So ultimately, does this finally just become part of the traditional IT operations motion, and it won't be such a unique circumstance?
Yeah, I mean, Rubrik is a good example of extending protection to OpenShift as well as Proxmox VE, right? I mean, there's definitely a focus there around. I would have to say it has to do with that application modernization, where organizations are moving from heritage environments to more what I would call today's standards, which is microservice and containerization. Obviously, data protection has to move and modernize with that, right? So if you're not doing that as a data protection company, you're going to be left behind, right? So leveraging the appropriate Kubernetes drivers for a stateful environment to make sure you're taking the appropriate snapshots. All of that is available and has been available for some time. So utilizing that tech stack in order to follow the application where it may go, that is incredibly important when you're looking at, like we were just talking about with OpenShift, being able to follow across different clouds, different architectures, different locations, from core to edge to different cloud locations. That making sure that you have the protection across each one of those different locales is incredibly important. That's what I'm seeing with the data protection space as well when it comes to application modernization. It's a different world, right? It's not just this encapsulated big monolithic application environment. It's microservices distributed across multiple environments, and understanding those different groupings of dependencies is really what these data protection companies need to be looking at.
All right, folks, you heard it here. There's an old saying about how small children, small problems, big children, big problems. Well, that same rule applies to clusters, it turns out. Hey, Paul, thanks for the show.
Thank you, Mike. It's great to be here.
All right. Back to you guys later, and thank you all for watching the latest episode. You can find this on Spotify and all your favorite other channels out there, plus the Cloud Native Now website, TechStrong TV. We'll see you next time.